Hey, we're going to talk for a little bit about how we round things off, but to significant figures. Now, this is a little bit different to rounding something to decimal places, although some of the techniques we're going to use are the same. So let's have a look and see what we mean. What if you were asked to round off this 3.2178 to three significant figures? All right, here are the steps. We're going to go through them. First thing is you work from left to right, and you start at the left of the number and you come in and you stop at the first number that's not a zero. So let's do that. We're going to start out here to the left. When I come in, I'm going to stop at the first number that's not a zero. Now, that makes no sense for this example, but it will in the next one. That's the number 3. All right, from there, I count out the number of significant figures. We've been asked to round this to 3 significant figures, so that's what we're going to do. So we're going to count across from there, 1, 2, 3. That bit there is where I'm going to stop. I'm going to chop it off there, but I need to look at the next digit after, and that's my critical digit. Just like we would round decimal places, I have to decide whether I round it up or leave it as is. If the critical digit, which is the one after where we're chopping it, is 5 or more, we round up. Otherwise, we leave it as it is. In this case, I'm going to round this up to 3.22. All right, let's have a look at another example. 0.04328 to 2 significant figures. All right, let's have a look. See, now remember I said we start from the left and we come in, but we stop at the first number that's not a 0. So we slide past those zeros and we stop at the 4. Now we're rounding it to 2 significant places. So I count 2 places, including the 4, and that's where I'm going to chop it off after that 3. But I need to look at the next critical digit, and if it's 5 or more, I round up. But in this case, it's less than 5, so I just leave it as it is, 0.043. Now you'll notice that is actually 3 decimal places, but it's 2 significant figures. So there's a little bit of a difference there. This one, 287, so 287,312 to 4 significant figures. I gave you 3 fingers. Don't know what happened. So let's follow the same process. Nothing's changed. I'm going to start out to the left, and I'm going to come in and stop at the first number that's not a 0. Happens to be the 2. I'm going to count out 4 significant figures. 1, 2, 3, 4. And normally I would chop that, but that doesn't make sense because I can't say, well, it's 2,873. That's nothing like 287,000. So because these numbers afterwards are not decimals, I need to look at them and decide just normally, am I going to round it up or not? Well, I'm not. But those 2 numbers, I can't just chop them off. I end up with a much smaller number, so I change them to zeros. Okay, because 287,300 is almost, well, it's very similar to 287,312, but it's got 4 significant figures. One last thing, sometimes you're asked to do significant figures with scientific notation. So previously we looked at how to do big numbers in scientific notation. So I'm going to take this big number here and I'm going to move the decimal place from the end to a point between or after the first digit. Okay, so it'll be 1.7, and I had to move it 7 decimal places to get it to that point, so it becomes times 10 to the 7. Okay, you can check out other videos on scientific notation if you're not sure how we did that. But the last step is now to round that to 3 significant figures, and we follow the same process. Okay, I come in from the left. Oops, I come in from the left. I count out the 3 places. I decide whether or not to round it up, and you'll see that my answer only has the 3 significant figures before the times 10 to the 7 bit. That is rounding to significant figures.